will go to 2.1, which is system overview. As you guys can see on my screen, I will explain what is our system overview. So basically, our objective is are to getting started with the EPM 240 CPLD. Next, our objective also familiarization with various design entry method. And lastly, our objective are creation of moderate complexity usable modules. So as you guys can see on the figure 2.1, our previous frequency is 50 megahertz, and then we have a clock prescaler to prescale it into 1 hertz, and then on this milestone we will build a BCD counter, and then next we build BCD decoder. And okay, now we are at 2.2, which is we want to build a BCD counter. So you guys can just save can just build a new block diagram file and then can save it as one. So right now we want to call up the LPM counter. So just write it LPM underscore counter. So the this is our LPM counter. So just okay, and then here you next. And then on this page, you change it into 4-bit only. So 4-bit only, and then you click next, and then you choose modulus, and then you take 10 modulus only. So okay, finish. And then here also just press finish. Okay, yes. Okay, so our everyone counter are set. So just put anywhere you want. Now we want to add a input port. So just add one input port here. Input port. Okay, so this is our input port. So we can add here. Okay, done. So this is our input port. Let's rename it into GCLK. So GCLK, and then we add the bus at the output port. So bus, choose bus, and then drag it. Okay, so this is our bus, and I suggest to rename it like this. Q square bracket 3 until 0. So okay, so I think that's all for the building of BCD counter. Now we at the 2.3, which is we want to build a BCD decoder. So just now we build a BCD counter, so right now we want to build a decoder. So for the decoder, just call up the symbol. So just double click on it. Okay, and then we type 7442. So this is a 7442 decoder that we want to use. So okay, so you just put anywhere you want. I will put this, and then you must add some regular wires to all input at the 7442. So let me take some space here. Okay, and then wire, let's put one wire here, one wire there. Sorry, my bad. Okay, one wire here, one wire here, one wire here. Okay, so sorry for my bad. Again. So 2 more wire here and here. Oh no. Okay, so there are 4 regular wires, and then we label it one by one with the Q Q0, and then here we name it as Q1, here Q2, here Q3. Okay, after we label it, now you can see our BCD counter connected to the BCD decoder. So as you guys can see, let's zoom up. Okay, so our BCD counter and BCD decoder are connected.
This is for Milestone 2.4, where we create the mapper. So this is the schematic diagram for mapper, where we have 10 input from Y0 to Y10. We have 4 AND gate and also 6 output gate from A to F. After we're done doing the diagram, we can start compilation. We need to make sure the top level entity is the mapper, and then we will get the successful compilation. After that, we go back to the schematic and go to file to create the symbol file for the current file. Then we save as the mapper as symbol file. As you can see, I have already done this. So to check, we can double click here and write mapper. Okay, so we can see there is the Y0 until Y9, same as here, and also A to F, and the name is mapper. Then for 2.5, we will be simulating the circuit. But first, we can take the schematic from 2.3, where it has the input GCLK and LPM counter, and also the 7442 BCD decoder. Then from 2.4, we have the mapper, and then we can insert it into this diagram. Then we connect it to BCD decoder accordingly, and also to output A until F. After we done creating the circuit, we can start compilation. Make sure the top level entity is correct, and then we will get the successful compilation. Then we go back to the schematic. After that, we need to create the waveform for the circuit. Here I've already prepared the waveform diagram. Make sure the input and output is correct. Then we can start the simulation. So this is the simulation for this diagram. 2.6 prescaler. For this, we need to create a Verilog HDL file, and then we enter this code. After that, we can run the simulation, but make sure we set it as the top level entity. Then start compilation. After we get a successful compilation, we need to turn this and create a symbol file. To do that, we go to create and then create symbol file for current file. Then there, the symbol was created successfully. After that, we go to the main file, which is here. I have the night final, and then set it into a top level entity. Okay, in here we can put the prescaler to the final schematic. After the prescaler is added, the circuit can no longer be simulated, so we can continue to the next step.
Okay, this is the last part, which is part 2.7, programming the CPLD. So for the first thing you need to do is you need to make sure that your quarters have been assigned to the correct device. So you can do this by going to the assignments and go to the device. And then you need to make sure that the EPM240 are included in the available device list. So if you didn't have this available device in this list, you need to change or you need to check the device family, make sure it become the next two. So if you already have the EPM240 in the available list, you just click close. Next, for the next part, you need to click on the assignment and go to the pin planner. So this is the top view of our CPLD. When then you need to change the input signal at the pin 64 into the clock signal, which is GCLK. You can just type on the symbol and change it in the node name. Then you need to assign 6 more pins where each of it represent the node from A to F. You can change it by clicking on the box in the location part, or you can just click on the symbol in the top view of the spell. Here I set the pin from A to F at the pin 74, 76, 78, 82, 84, 86 and 86. I set the pin closer to each other because we can easily connect it and find it on the hardware of the CPLD. You can close it and recompile again. So if there is no error, so this is the final circuit should look like. You can see there will be labeled the pin 64 in the input and other pin at the output from A to F. After that, you can start input the program or our design to the hardware CPLD. In doing that, you click on the tools and find the programmer. So for the first thing, you need to set up the hardware. So you go to click on the hardware setup. So as you can see here, there are no USB blaster. So you just need to plug in your USB blaster also with the USB for the power supply to the CPLD. So I now close again and open it again. So now you can see the USB blaster head available at the hardware items. So you just change it to the USB blaster. If you still can't find the USB blaster on the available items, so you need to go to the device manager at the start window and start to set up the USB blaster. After that, you click on the add file and find the file at the output file and select the .pof file. And then you click on the three boxes to tick it. And then to input the design in the or coding in our CPLD, you just click on start, and here it shows that the input the or coding process had been successful. And then we will moving on to the hardware simulation part. Okay, this is the hardware simulation for Milestone 2. So as you can see, the USB blaster and USB drive for power supply have been connected to the CPLD. So the LED also had been connected to each pin that had been assigned for node A until F, which are the pin 74, 76, 78, 82, 84 and 86. Each had been connected using the male-female jumper to the LED. And also for the VCC also have been connected to the COM part of the LED. So as you can see, this is the sequence of the blinking LED, which is going from A until F, and it will also go backward reversely the sequence, and go from A to F again and again when the power had been connected.